This lesson is over inverse relations. Here's a few definitions. A function is where each input has exactly one output and passes the vertical line test, or the VLT. If we switch the x and y coordinates, then we have what is known the inverse relation. The graphs of the original and the inverse are always reflections of each other across the line y equals x. If the inverse relation is also a function, it is named f inverse, and the original function f is called 1-to-1. Now, here's what 1-to-1 really means. 1-to-1 means the original is a function and the inverse is a function. Now, when you think of function, that means it passes the vertical line test. If it is not 1-to-1, that means the original is a function, but the inverse is not a function. Example 1 says find the inverse, and part A says of the relation, and what we have is a collection of points. We have the ordered pair 0, 1, 5, 6, -4, -2. Now, because the direction says find the inverse, well, we just learned to find the inverse, what must you do? You simply switch the x and the y, which means instead of the ordered pair 0, 1, it's now written as 1, 0. Instead of 5, 6, it's now 6, 5. Instead of -4, -2, we now write it -2, -4. Part B wants us to find the inverse of the equation, and this time the equation is y equals 2/3 x plus 5. Again, the direction says find the inverse. The inverse simply means to switch the x and the y. Well, in the equation, the y gets replaced with an x, and the x gets replaced with a y. So your new equation is x equals 2/3 y plus 5. Now, how to determine if a function is 1-to-1 visually? And in this case, we use the horizontal line test, or HLT. As a reminder, horizontal lines go from left to right. So let's look at the rules. If a horizontal line crosses the graph of a function only once, then the function is 1-to-1, which simply means the inverse is also a function. So what might this look like? Well, here's a graph. We can look at it, the green graph, and tell it is a function because it passes the vertical line test. But to determine if it is 1-to-1, we must apply the horizontal line test. So we apply a horizontal line anywhere on the graph. And notice, no matter where you place the horizontal line, it will only cross the green graph at one time, which means this function is 1-to-1. Now, if a horizontal line crosses the graph of a function more than once, then the function is not 1-to-1, which means the inverse is not a function. So to see what this may look like, we have a graph. We know the given graph is a function because it passes the vertical line test, but it does not pass the horizontal line test. Notice, if you place a horizontal line anywhere on this graph, it will cross it more than once. And when we say this function is not one-to-one, again, that simply means the original is a function, but its inverse, meaning if I were to switch the x and the y, would not be a function. Example 2, identify the following. And so for A and B, we have graphs. Take a moment now to draw these on your paper. All right, looking at graph A, we are asked 3 separate questions. Let's start with the first one. Is this a function? Well, notice the word function. Function, it means it must pass what test? Well, that would be the vertical line test. So look at the graph of A, and if you were to place a vertical line anywhere on this graph, would it only cross it one time? And the answer is yes, which means this is a function. Next, it asks, is it one-to-one? Well, one-to-one means we have to use what test? Well, this is the new one. That would be the horizontal line test. So take a moment now to draw a horizontal line anywhere across the graph. Does it cross it more than once? Since the horizontal line will cross it more than once, that means this is not one-to-one. Now the last question states, is the inverse a function? Well, remember the phrase one-to-one. One-to-one means the original is a function and its inverse is a function. Well, was graph A one-to-one? No, which means the inverse is not a function. For graph B, it asks the same questions. Is it a function? Because it says function, it means use the vertical line test. And notice the graph would pass the vertical line test, so yes, this is a function. For the second question, it asked, is this one-to-one? Well, one-to-one means you must use the horizontal line test. And if you were to place a horizontal line anywhere on this graph, notice it would only pass it once. Since it only passes through it once, that means yes, this is one-to-one. The last question is the inverse a function? And again, your reminder, the definition of one-to-one means original is a function and the inverse is a function. Because we said this is one-to-one, we are saying the inverse is also a function. Okay, let's do some exploring. This one says to graph y equals 1/2 x plus 1. And the first thing we're going to do is complete a t-chart, and then we're going to graph it. So take a moment now to complete the t-chart. Hopefully you found the following corresponding values. Check your t-chart with mine, and if so, go ahead and plot your points and see what the shape of this looks like. And hopefully your graph looks the same as mine. So now that we have a visual representation of this equation, we're going to look at some other parts to it. So the second part regarding that equation is, now that we can look at it, I want to know what is the domain. Now remember, domain corresponds to your x values, which makes you think of the x-axis, which goes from left to right. So looking at the graph, the furthest left we can go, because we see an arrow, means negative infinity. And as we look to the right along the graph, we see another arrow, which means positive infinity. So that would be your domain. Next, we want to look for the range. Again, looking at the graph, the range corresponds to the y value, which makes you think of the y-axis, which goes up and down. Now remember, in interval notation, you have to write smallest to largest, which means following the y-axis it has to go from the lowest to the highest. And again, because we see arrows as we go down and arrows as we go up, the range will also be negative infinity to positive infinity. Now, the next question states, is this a function? Well, remember, if it's a function, what do we use? The vertical line test. And so if you were to place a vertical line anywhere on the graph, would it pass the vertical line test? Yes, it is a function because it does pass the vertical line test. Now, since we're saying this is a function, I can now rewrite this equation in function notation, which simply means you take out the y and in its place put in f of x. And now that we can read this as f of x equals 1/2 x plus 1. All because it passed the vertical line test, which guarantees this is a function. Now, the question is this function 1-to-1? Well, for it to be 1-to-1, what test do we apply? Well, that would be the horizontal line test. So if you were to draw a horizontal line anywhere on the graph, does it only cross at one point? And it does, which means yes, this is 1-to-1 because it passes the horizontal line test. So what does that really mean? Well, that means the inverse will be a function too. So let's look a little bit more. Okay, so we just did the horizontal line test, which means the inverse is going to be a function. So now let's see what is going to be the inverse function. So to do that, we start with the original equation of y equals 1/2 x plus 1. Now remember, to find an inverse, what do? Well, you simply switch the x and the y. And so our new equation is x equals 1/2 y plus 1. So now that we've switched it, what do? Well, to find the inverse function, it means you need to get y by itself. So looking at the equation, notice we have y on the right side of the equation. Well, what else is on the right side but does not have a y attached to it? Well, that would be the plus 1. So how do you undo adding 1? You subtract 1. So we subtract 1 from both sides, which now gives us x minus 1 equals 1/2 y. Now, we're closer to getting y by itself, but now we notice we have a 1/2 times a y. When you have a variable multiplying a fraction, to get rid of that fraction, you simply multiply by its reciprocal, or by the flipped version of the fraction. Well, the fraction 1/2, if I flip it, becomes 2/1, or 2. So what we're going to do is we are going to multiply the right side and the left side of the equation by 2. And so on the left side, that looks like the distributive property, which becomes 2x minus 2 equals y, because the 2's reduce. And so notice y is now isolated. That's great. But now we want to write it in function notation. I cannot call this f of x because it's not the original. Instead, because this is the inverse, I must write it as such. So f inverse equals 2x minus 2. Now that we have the inverse function, we want to do the t-chart and to graph it and see what it looks like. Now, recall, we have the original t-chart. To find the inverse, what do? Well, you simply switch the values of x and y. So our first original ordered pair was -4, -1. The inverse would simply be -1, -4. Go ahead and complete the t-chart by switching your x and y values. Hopefully you have the same t-chart as me. So now that you have the collection of the t-charts, that means you are now ready to plot your points and graph the inverse function. Take the time to do that now. Hopefully your graph looks the same as mine. Now notice our graphs, they're on the same graph, but earlier we mentioned that the graph of the original and the inverse will always be reflections of each other across the line y equals x. Well, y equals x is drawn on the graph now. Notice the purple graph, which is the original, does appear to be a mirror image of the green one, which means this satisfies the original and its inverse will always be reflections. And this will be true for all inverse functions or all inverses. Now, going back to the t-charts, notice our original t-chart, our x values, that's known as our domain. But whenever you switch your x and y, that domain now becomes the range of the inverse. And on the original, our range, whenever we switch it, now becomes our domain of the inverse. I hope you see that too. So what that leads us to is the one-to-one functions and inverses. There is a nice relationship that happens. So if I have this notation, what does that mean? Well, that means domain of the original function. Well, domain of the original function, what does that mean in regards to the inverse? Well, domain means x, but if I switch it to create the inverse, that means that x now becomes a y, and y is represented as the range of the inverse. Now, the range of the original function is normally used with the letter y. But if I want to find its inverse, remember inverse means to simply switch the x and the y. That means this y turns into an x and would become the domain of the inverse. And we just saw this on the previous problem. Example 3, assume the function is one-to-one and without graphing, find the following information. We're given the function f of x equals 1 all over x plus 5 minus 3. So part A says find the inverse function. So on the side of my paper, I'm going to work this out. For part A, it says find the inverse. Well, that means we must start with the given function. We cannot do anything when it's written in f of x notation. We must change f of x into a y. So we have y equals 1 all over x plus 5 minus 3. Now to find an inverse, what do? You switch the x and the y. So now we have x equals 1 all over y plus 5 minus 3. Now that we've switched them, now we want to try to get y by itself. Well, notice y is on the right side of the equation. What on the right side is not very close to the y or very close to the fraction at all? Well, that's the minus 3. So to undo subtracting 3, we must add 3 to both sides. So we have x plus 3 equals 1 all over y plus 5. Now notice we're trying to get y by itself, but y is in the denominator of a fraction. Well, recall, you can get rid of fractions by multiplying the left side and the right side by the denominator. And in this case, our denominator happens to be y plus 5. So we will multiply the right side and the left side by y plus 5. Now on the right side, notice y plus 5 in the top and y plus 5 in the bottom, those reduce. On the left side, leave it as you see it. So we have y plus 5 times x plus 3 equals 1. Now, our goal is to keep the value that has the y. Now notice y is inside a grouping symbol, that y plus 5. We want to keep that piece. But I don't want the piece that has the x plus 3 because there's no y. So how do you undo multiplying by x plus 3? Well, you divide by x plus 3. As long as what you do to one side, you must do to the other. So the x plus 3's reduce, leaving you with y plus 5 equals 1 all over x plus 3. Now we're one step away from having y by itself. We have to get rid of adding 5, which means we need to subtract 5 on both sides. So now we have y equals 1 all over x plus 3 minus 5. Since y is by itself, now we can write it in function notation, but because it's the inverse, you have to write it as f inverse equals 1 all over x plus 3 minus 5. And so now we've answered part A. Now part B says find the domain of f of x. Now domain means I'm concerned with my x values. But in this case, I don't have a graph to look at. So what we do is we look at the original function. F of x equals 1 all over x plus 5 minus 3. Now recall, for domain, there's only two key issues that we are on the lookout for: fractions and radicals. Well, what do you see? Notice, we have a fraction with a variable in the denominator. So we have to recall what the approach is. When you have a fraction with a variable in the denominator, you simply set the denominator and say it cannot equal 0. And in this case, our denominator is x plus 5. And so we want to try to solve for x, and to do that, we would need to subtract 5 on both sides, which tells us x cannot equal negative 5. Well, to better understand this and write the domain in interval notation, we need to draw a number line. And when we say x cannot equal negative 5, that means there is a hole or a gap or a missing value on the number line. But I can use all the numbers to the left of negative 5 and all the values to the right, just not negative 5. And so now that we see what we can use, now we need to write it in interval notation. We read a number line from left to right, starting on the left because there's an arrow that indicates negative infinity, and we shade to the right until negative 5. But we use a parenthesis because we cannot include the negative 5. Because there's a hole or a missing value, we use the union, and we pick back up on the other side of negative 5 and continue for forever, which would mean negative 5 to infinity. That is your domain for the original function. Now we just learned that the domain of the original function is the same thing as the range of the inverse because we switched the x and the y. So if we have the answer to part B, which is find domain of f of x, that means we actually already know the range of the inverse. which is also going to be negative infinity to negative 5 union negative 5 to infinity. Now, looking at part C says find the domain of the inverse function. So again, I'm doing my side work. Domain of the inverse function. So let's look at the inverse function. All right, now we have to think of the two issues for domain. That would be fractions and radicals. Well, what do we have? Well, we have a fraction with a variable in the denominator. So recall, the approach to find the domain is to set the denominator cannot equal 0, which in this case is x plus 3. So we need to solve for x by subtracting 3 on both sides, and we find x cannot equal negative 3. So we found the number it cannot be, but what does this look like on the number line? Well, on the number line, at negative 3, we will have a whole. But I can include all the values to the left of negative 3 and all the values to the right, which means my interval notation would be negative infinity to negative 3, parenthesis, because I do not include negative 3. Because I have a whole, I would use the union, pick back up on the other side of negative 3, and continue to infinity. So your domain of the inverse function is negative infinity to negative 3 union negative 3 to infinity. Now again, notice at the bottom there is a neat relationship between one-to-one functions and their inverses. If you have the domain of the inverse function, automatically you have the range of the original function, which means part D would be negative infinity to negative 3 union negative 3 to infinity.